Hello students, welcome to this computer class. In this class, I will discuss about the second chapter, which is Introduction to Number System. I have divided this chapter into two parts. So in this video, I will discuss about the first part, which is up to octal number system. The computer system comprises hardware and software. Both hardware and software work together so that the computer can process data and instruction and give result. When we type a character on the keyboard, the computer converts and stores it in the form of strings of zeros and 1 because computer only understands 0 and 1. The symbols 0 and 1 are together called binary digits or bits. So full form of bits is binary digits and form the binary number system. The memory of the computer can be thought of as a vast group of cells. Each of these cells contains one bit of information. That is, each cell contains 0 or 1. In this chapter, we will learn about the hardware and software in a computer system and the different number system. So, there are 4 types of number systems. First is binary, decimal, octal, hexadecimal. So, first topic is hardware. Hardware comprises the physical components that make up a computer system. You can touch and feel the hardware. Hardware can be internal or external. So this is the definition of hardware. Next is examples of internal hardware are motherboard, CPU, disk drive and SMPS. And examples of external hardware are input devices like keyboard, mouse, joystick, output devices, printer, monitor, storage devices, hard disk, CD, DVD, pen drive, etc. Next is software. Software is a set of computer programs and procedures that provide instruction to the hardware on what to do and how to do it. A program is a set of instructions that perform a particular task. So this is the definition of software and program. Next is there are two types of softwares. They are system software and application software. First is system software. System software is a set of one or more programs that is designed to control and manage the operation of a computer system. The system software works as an interface between hardware and the user. Examples of the system software include operating system, device drivers, language processor, etc. Next is application software. Application software comprises computer programs that are designed to help the user in performing a certain type of work. Application software pertains to one specific use or application. Example of application software include general purpose software such as word processor. Word processor means Notepad, WordPad, MS Word. Spreadsheet software like MS Excel. Specific software such as payroll system, inventory system, accounting system, etc. Next is storage units in the computer. First storage unit is bit. It is the smallest data unit in a computer which contains a single binary value, either 0 or 1. A combination of bits is used to store information and data in the computer memory. The combination may be a byte, a nibble, or a word. depending on the number of bits it can store. So next unit is byte. A combination of 8 bits forms one byte. Each byte represents one character such as A, B or small a, small b, 1 or 2, etc. Next is nibble. A nibble is a group of 4 bits. It can store one decimal digit in its binary form. Next is word. A group of bits representing data or instruction that forms the basic information unit of a computer is called word. It is a group of fixed number of bits processed as a unit in a single operation. It varies from computer to computer but is fixed for each computer. Next, a computer stores information in the form of words. A word may be 8, 16, 32 or 64 bits. The size of a word depends on the architecture of the computer. A machine with 16-bit word is slower than one with 32-bit word. The length of a computer word is called word size or word length. Next is other storage units in the computer. So first is kilobyte, then megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte. So 1 kilobyte is equal to 1024 bytes or 2 to the power 10 bytes. 1 megabyte is equal to 1024 kilobyte or 2 to the power 10 kilobyte, and here is the bytes representation. 1024 into 1024 bytes. Next is gigabyte. 1 gigabyte is equal to 1024 MB means megabyte or 2 to the power 10 megabyte, and here is the byte representation of gigabyte. So 1024 into 1024 into 1024 bytes is equal to 1 gigabyte. Next is terabyte. 1 terabyte is equal to 1024 GB or 2 to the power 10 GB. Here is the bytes representation of terabyte. So 1024 into 1024 into 1024 into 1024. Next is petabyte. 1 petabyte is equal to 1024 TB or 2 to the power 10 TB. This is the byte representation. Next is 1 exabyte. 1 exabyte is equal to 1024 petabyte or 2 to the power 10 petabyte. Here is the byte representation. Next is zettabyte or ZB. 1 zettabyte is equal to 1024 exabyte or 2 to the power 10 exabyte. This is the bytes representation of zettabyte. And last one is yottabyte, which is YB. So 1 yottabyte is equal to 1024 zettabyte or 2 to the power 10 zettabyte. This is the bytes representation of yottabyte. Next is number system. So there are 4 types of number system: binary number system, decimal number system, octal number system, and next hexadecimal number system. So first number system is decimal number system. The decimal number system is what humans use most commonly. So we use decimal number system. It is composed of 10 numerals 0 to 9. So in decimal number system there are 10 digits 0 to 9. Using these digits you can express any quantity. It is also called the base 10 system. So decimal number system is also known as base 10 system because in decimal number system there are 10 digits 0 to 9. Base of the decimal number system is 10 and the base number is also called radix. The decimal system is a positional value system. It means each digit has its own position. For example, like 256, in this digit, the position of 6 is ones, position of 5 is 10 and position of 2 is 100. And these positions are expressed by power of 10. Like here 6, the position value of 6 is 10 to the power 0. Position value of 5 is 10 to the power 1. Position value of 2 is 10 to the power 2. Next, the rightmost digit has the least positional value. Therefore, it is called least significant digit or LSD. So the rightmost digit of any number is called least significant digit because it has least positional value. Like in the previous example, in 256, 6 is the rightmost value. So 6 is the LSD. So least significant digit is 6. Next, the leftmost digit has the maximum positional value. Therefore, it is called most significant digit or MSD. So, the leftmost digit of any number is called most significant digit because it has maximum positional value. So, in this example, 2 is the MSD because 2 is the leftmost digit and it has the maximum positional value. Next, now let us consider the decimal number 49.12. The decimal point separates the whole number on the left from the decimal digit on the right. So, in 49.12, here 49 is the whole number and 0.12 is the fractional part. So, here the LSD is 2 and MSD is 4 and the value and the position value of 9 is 10 to the power 0 and 4 is 10 to the power 1. But in case of fractional part, the position of 1 is 10 to the power minus 1 and 2 is 10 to the power minus 2. Next, the positions to the right of the decimal point are called decimal places. So, these number is the decimal places. Next, the digit at the first decimal place shows the number of tens. Like here, first decimal place shows the number of tens. In our example, it is 1/10. So, 10 to the power minus 1 means 1 by 10. The second decimal place shows the number of hundredth and so on. In our example, means in this example, there are 200 means 10 to the power minus 2 means 1 by 100. Next is binary number system. The computer system is designed on the binary number system. The binary number system has a base of 2. So, in case of decimal number system, the base is 10 because in decimal number system there are 10 digits from 0 to 9. In case of binary, the base of binary number system is 2 because binary number system has only 2 digits 0 and 1. The binary number system is also a positional numbering system wherein each binary digit has its own value or weight, which is expressed as a power of 2. So, in case of decimal number system, the position value is expressed as a power of 10, and in case of binary number system, the position value is expressed as a power of 2. Suppose it is a fractional binary number. Here is an example 1011.0101. So, the MST is 1 and the LSD is this, and the position value of whole number start from right. So, 2 to the here position value of 1 is 2 to the power 0, position value of 1 is 2 to the power 1, next position value of 0 is 2 to the power 2, next position value of 1 is 2 to the power 3. And in case of fractional part, the position value starts from left. So, value of the position value of 0 is 2 to the power minus 1, position value of 1 is 2 to the power minus 2, position value of 0 is 2 to the power minus 3, and the position value of 1 is 2 to the power minus 4. For a binary number, the binary points separate the whole number part from the fractional part. The place values of the digits to the right of the binary point are obtained by raising 2 to successive negative power, like here 2 to the power minus 1, negative power. Next is octal number system. The octal number system has a base of 8. It has 8 digits 0 to 7, 0, 1, 2, 3, 4, 5, 6 and 7. So, there are 8 digits. So, the base of the octal number is 8. The octal number system is also a positional numbering system. Each octal digit has its own positional value or weight, which is expressed as a power of 8. As an example, consider 1267.12, an octal number system with a fraction. So, here is the positional value. So, the whole number, the positional value start from right to left, and in case of fractional part, the positional value start from left to right. So, here positional value of 7 is 8 to the power 0. Next, positional value of 6 is 8 to the power 1. Next, positional value of 2 is 8 to the power 2. Next, positional value of 1 is 8 to the power 3. And in case of fractional part, positional value of 1 is 8 to the power 1, positional value of 2 is 8 to the power minus 2. As in the decimal and the binary number system, the radix point separate the whole number part from the fractional part. The place value of each digit to the left and the right of the radix point is equal to 8 raised to successive positive or negative power respectively. So that's all for today. In the next video, I will discuss about the second part of this chapter, which starts from hexadecimal number system.